Assalamualaikum and hi guys, this is 2.3 electronic configuration. What's meant by electronic configuration? Electronic configuration of an atom or ion describes how electrons are distributed among the various orbitals in the main shells, which is the principal shells, and in the subshells of the atom or ion. So during 2.2 in the quantum mechanical model, we've learned that each orbital, each principal shell, which is main shell, for example, n, okay, principal quantum number n equal to 1, 2, 3, 4, and so on, will contains of its subshell, which is known as L, okay, azimuthal quantum number. So, for example, 1s shell 1 n equal to 1, so it will have 1s subshell. When n equal to 2, it's going to have 2s and also 2p subshell and so on. So here are the three rules used to assign orbitals. Rules for assign electron to orbitals. So that's mean when you want to fit the electron into its orbital, because we know that orbital is the place to find where to find the electron, right? So we need to use these three rules together. Okay, cannot choose either one, but you must use these three rules. Okay, the first one Aufbau principle, second one is Pauli's exclusion principle, and third one is Hund's rule. So what's mean by Aufbau principle? Okay, so electron will fill the lowest energy orbital first and the other orbitals in the order of ascending energy, right? So this is the diagram of energy level diagram, starting from principal quantum number n equal to 1 up till n equal to 4, right? Actually, got more principal quantum number, but in this diagram, it's just up to when n equal to 4. So you can see that when n equal to 1, there is one s subshell present. N equal to 2, there is 2s and 2p. Meanwhile, when n equal to 3, there are 3 subshells, 3s, 3p, and also 3d. Meanwhile, for n equal to 4, there are 4s, 4p, and 4d. And this is for n equal to 5, we have 5s and so on. Okay, so now the lower, okay, as you can see, energy level increases from bottom to top. So when we want to fill in the electron, we must fill in the lowest energy orbital first, which is from n equal to 1, right? And then each orbital, remember, each orbital can fit up to 2 electrons, right? So that's mean you must start to fill electron inside 1s orbital first, and then if you still got more electrons, so you have to move up, and then if this orbital also full, you need to move up to this orbital. So as you can see, 2p subshell consists of 3 orbitals. So that's mean 3 times by 2, so 2p orbitals can fit up to 6 electron, right? So 6 electron. 6 electrons, 2 electrons, 2 electrons, right? 2 electrons, 6 electrons, 3 electron, and this we have 5 orbitals. So that's mean 3d orbitals. 3d subshell contains of 5 orbitals. So 5 times by 2, 3d subshell can fit up to 10 electrons. Okay, so this is the first rule. That means if you got 4 electrons, okay, that 4 electron will be fit into 1s and also 2s subshell. Okay, so this is what we call as the rainfall diagram. Okay, so first you must know when n equal to 1, there is just one subshell on the axis, which is 1s. When n equal to 2, there is only 2 subshell axis, which is 2s and also 2p. When n equal to 3, there are 3 subshells, okay, 3s, 3p, 3d. And when there are 4 subshell, when n equal to 4, there are 4 subshells. When n equal to 5, there are also 4 subshells. So we need to do the rainfall diagram, okay, in order to fill the orbitals, right? So starting from 1s, okay, 2s, and then 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. Usually in our syllabus, you will be asked, okay, just to fill the orbital up till 3d, right? So far in our syllabus, just up till 3d orbitals. So if you have to arrange, okay, the orbitals, okay, or the subshell, okay, in order of increasing energy. So you must start with the lowest energy subshell first, or lowest energy orbital first. So that's mean 1s has the lowest energy, followed by 2s, followed by 2p, 3s, 3p, 4s, and so on. Right? So as we can see here, this is very important part. Okay, between 4s and also 3d, okay, 4s will have a lower energy compared to 3d. Therefore, after we completely fill the 3p orbital, the next electron must be filled into 4s orbitals, right? And then after the 4s orbital is full, then barulah you isi ke dalam 3d orbital. Okay. So as for example, okay, let's say we have 5 electrons. So the first 2 electron goes into 1s orbital, next electron going to 2s orbital, so we still have 1 remaining. So this 1 electron is going to fill up into 2p orbitals. So next, the second rule is called Pauli exclusion. So exclusion means exclusive. Exclusive means contoh macam if you buy exclusive things, okay, exclusive means one design dari satu saja. Contoh macam tu lah. Contoh bawal eksklusif kan. So for that color and also for that design, there are only 1 pieces available. So the same for electrons. Okay, Pauli exclusion principle said that no 2 electrons in an atom can have the same 4 quantum numbers. Okay, because there are 4 quantum numbers NLMS. Okay, it could have the same N, the same L, the same M, but S must be different. For example, we have this helium. So if you draw, okay, this is called the orbital diagram of helium. Since helium consists of 2 electrons, okay, these 2 electrons will be fit into 1s orbital, right? So when you draw the orbital diagram, you must make sure, okay, the arrow are pointing upwards and also downwards, okay, in opposite spin. Why? Because opposite spin represent different S values. Okay, S is the quantum number, okay, that shows the spinning motion of electron. So for example, 1s orbital, n equal to 1, l equal to 0, m equal to 0. But then since these 2 electrons is in the same orbital, so you must make sure it have opposite direction of spinning, right? Because electron will repel another electron. Therefore, in order to fit it in the same room, in the same house, in the same orbitals, so you must make sure that, okay, it is spinning in the opposite direction, clockwise and also anti-clockwise, so that it will not repel each other. Therefore, when you draw it correctly in the opposite direction, that shows that it consists the different value of S, which is one is positive half and the second one is negative half. For example, if you draw the orbital diagram like this, that's mean you show that both electrons are spinning in the same direction, which is not possible. Therefore, okay, this is not permitted. Same for this one. For example, you draw both pointing downwards, which are spinning in the same direction and have the same S values. So this is not permitted. So remember, Pauli exclusion means exclusive. Each electron Okay, each electron in an atom should never have all the same four quantum numbers. So it can have the same n, the same l, the same m, but not the same value of s. Okay, the electron must be spinning in the opposite direction in order to prevent repulsion. Right? So now the last rule is called the Hund's rule. So Hund's rule states that when electrons are added to the orbital of equivalent energy, right? Orbital of equivalent energy. So please focus on these words, orbital of equivalent energy, or we call degenerate orbitals. Degenerate orbital. This is the term. So what's meant by degenerate orbital? Degenerate orbitals mean orbitals of equivalent energy. Energy yang sama. Okay, so each orbital are filled singly. Setiap orbital diisi secara satu-satu lah, with electron of the parallel spin first before it is back. Okay, for example, nitrogen, okay, proton number 7, the electronic configuration is 1s2, 2s2, 2p3, right? And these three electrons should be filled up singly first. So 2p orbitals is an example of degenerate orbitals. Degenerate orbitals. Okay, because 2p subshell contains of three orbitals of the same energy, okay, of the same energy. So when we reach out to fill in the degenerate orbital, okay, please make sure you fill the three electrons singly first, okay, in the same spin, for example upward spin. And then if you still got one remaining, for example for oxygen, okay, oxygen have 8, right? 8 proton number. So you have used up 7, and then another electron you should add in here. That is example for oxygen. But please note that, okay, you cannot fill like this. Okay, when it comes to degenerate orbitals, according to Hund's rule, you cannot pair it first and then fill in another orbital. No. Okay, for degenerate orbitals, you must fill in, okay, all the orbitals singly first, and then if you still got remaining, then baru you pair up. Okay. So how to know the degenerate orbitals? So you can see here, this is the energy level diagram. So we can see that 1s subshell consists of just one orbital. So it got no orbital of the same energy, right? No, you can see for 2s, okay, this is the energy level for 2s. 2s also consists of one orbital. Meanwhile, for 2p, okay, this is the energy level for 2p. Okay, so this 2p subshell contains of 3 orbitals with the same energy, right? These 3 orbitals have the same energy, so we see that this is the degenerate orbitals. Orbitals of the same energy. Okay, so can you spot as an example of degenerate orbitals? Right, so we have 3p, it's also degenerate orbitals, 3d, 4p, and also 4d. Remember, what's meant by degenerate orbitals are orbitals of the same energy.